Welcome to this video on the introduction to polynomials. By the end of this video, you should be able to classify a polynomial by degree. You should also be able to classify a polynomial by number of terms, and you should be able to write a polynomial expression in standard form. All right, so just to kind of review from hopefully what you can remember from before, is we have a couple of review items for combining like terms. So a like term are things that are exactly the same that you're allowed to add or subtract to each other. So let's take a look at this first one. When we're looking across, I notice that there's some multiplication that has to occur, so that needs to happen first. So I'm just going to start, I'm going to keep the 4y. I'm going to take care of this multiplication. That 2 next to the parenthesis is telling you need to distribute the 2 through. So we're going to take the 2 and distribute to both of those, so that when you distribute, that's multiplication. So it's 2 times x, so that's a positive 2x. 2 times 10 is a positive 10. Then we have negative 3x plus 5y. All right, so like terms, you want these terms to be exactly the same. So let's take a look at what we've got and if we can make them be exactly the same. So we have a 4y. Our first term is 4y. So I'm just going to put a box around it. Really, there's a positive sign in front of it because there's nothing listed there. Is there anything else with just a y? So when I go across, this positive 5y is just a y. These guys are like terms. That means we're allowed to combine them. So I have to look. This is a positive 4y plus 5y. So this answer would be 9y. Okay, that's just the y's. Let's look at the next term. I have an x. So I'm going to use a circle on this to kind of give us a visual of what else is like the x. Just x. This doesn't have an x. This just has an x with it, so I'm going to circle it. So this is a positive 2x minus 3x. So 2 minus 3 is a negative 1, and then we're going to keep the x. And then our last one that we're going to look at, there's nothing, everything else has been circled or boxed off, is I have this positive 10. There is no other just numbers available for this one to combine to, so you just bring it down plus 10. So that would be your final answer on that one. All right, let's try it again, see how we do. So we have 3x squared, 9x, negative 2, negative 5x, plus x squared, plus 8. I always like to look through before I really start. So there's nothing to distribute like we did on this one. We had to take care of this multiplication first. So I'm just going to kind of look. The first thing in line is this 3x squared. And that's really a positive. So I'm just going to write the positive there to remind myself. And I'm going to look, are there any other x squared terms? And I look, I see there's an x squared right there. And that's a positive x squared. Now remember, if you have a variable and there's no number in front, that number is actually 1. So I have a positive 3x squared and a positive 1x squared. So when I add them together, I get 4x squared. All right, let's go on to our next one. The x term is next. So see, the shape doesn't actually matter. It's just to help me match. So a single x, that has a single x, and I don't see any, and none of the other terms have a single x. So I'm going to put a box around it. These guys are like, so positive 9x minus 5x would be a positive 4x. And then I have a constant. That means it's a number without a variable. I have 2 of those, just numbers. And this one's a negative 2 and a positive 8. And negative 2 plus 8 is a positive 6. And that will be our final answer on that. All right, so that's kind of a basis of some of the things we're going to be talking about. And we're going to learn, I've been using the word term and different things, and so we're going to get further into that and what's going on. So our first question is, what is a polynomial? So a polynomial is an algebraic expression that consists of many terms. And the word terms, which I use several times when we are doing our review, and it's even in combined like terms, terms are separated by a plus sign or a minus sign. So it helps you distinguish between one term and the next. So when we do notes, this would be the time. There are several things to write. Pause the video, write these down, and then come back when you're ready to get the next section. All right, for our next section, we're going to learn how to classify polynomials by degrees. So out here in our notes, we have our topics out on the side and then the notes that go with them in here on the inside. So a degree, well, what is a degree? So when I refer to a degree, I am referring to the highest exponent in the expression. So you want to look to see what the highest exponent is. And I want to make a special note here that the highest exponent, that it needs to be on a variable. Okay? And that'll become important in a minute when we talk about this chart that's below. So the degree is the highest exponent in an expression, and it has to be on a variable. Okay? So we have several that we're going to talk about. There are more than what we're talking about. These are just the ones that we're going to talk about in Algebra 1. So one thing, I use this term up here. I use the word constant. Okay? And what a constant has a degree of 0. And the reason for that, so here's an example. You see how there's no variable? It's a degree 0 because there's no variable. Okay, so constant meaning it's not going to change. If you put a variable next to it, it changes depending on what number the variable is. That's why a constant is not going to change. It's the number. -4, 1,532,000, -10 billion. You know, those are all constants. They're not going to change. If you add a variable to it, then it's no longer a constant. Okay, then we could have a degree of 1. So when we look at our expression here, you see this variable right here. So this is a constant. 12 is a constant. But you have a variable on the 7. There's nothing written there. When there's nothing written there, it's an understood 1. If your highest exponent on your variable is 1, the shape it would make if you were to graph it would be linear. Okay, so if we graph this expression, it would be a line. All right, so then we have a degree of 2. So take a look at our expression here. You have two variables. This variable has an exponent of 1. This variable has an exponent of 2. 2 is bigger than 1. So 2 is the greater of the exponents, the highest exponent. So if your highest exponent is a 2, it's something we call quadratic. We're going to be talking a lot about these in the second semester. If we were to graph this on a graphing calculator, it would look either opening up, it's a U-shaped graph, or opening down. Okay, and of course a line is just a straight line. Okay, so these have graphs associated with them. What we're really wanting to get is if the highest exponent is 1, it's linear. If the highest exponent is 2, is quadratic. And then when we look, take a look at this example. The highest exponent there is 3, because 3 is greater than 2, and this is a constant, so it doesn't have an exponent. So if your highest exponent is 3, that is called cubic. We will not be doing a cubic in Algebra 1 as far as graphing them, but we will when we're talking about classifying by degree. A cubic is a really fun looking graph. It kind of goes up and down a little bit and back up again. And the last one we're going to talk about, Algebra 1, take a look at your example here. The highest degree is 4. This variable has an exponent of 1 because there is nothing written there. 4 is greater than 1, so the biggest is 4. And we call that quartic. Now, I want to caution you. 2 is quadratic, 4 is quartic. Quadratic sounds like 4, but it's not. So you just have to memorize that the 2 is quadratic and the 4 is quartic. And I'm telling you, there is vocabulary on the test about this, so be very careful. So this is classifying by the highest exponent, or the degree. Another way we like to classify is by the number of terms. So remember when I wrote up here, terms are separated by a plus sign or a minus sign. So when I look at my example, do you see how this number has no plus sign or minus sign? That is only one term, okay? And we call one term a monomial. So we got mono means one, and then meal. Okay. Now these are all going to end in meal, so I'm just going to write that down. And we're going to work on the prefixes because that's what tells you some information. Okay, if there's two terms, so if you look, there's your minus sign. So we have a term here and a term here. That is two terms, and a prefix for two is bi, like a bicycle has two wheels, so this would be a binomial. Okay, so bi means two terms, binomial. This one, if there's three terms, and if you look, you see there's a plus and a minus, there's both, so this is one term, this is two terms, this is three terms. They're separated by the plus and minuses. A prefix for three is tri, like a tricycle has three wheels. So we have trinomial. Okay. Now, we could go on with this forever and ever and ever, but for Algebra 1, we're going to stop with this last one. If there are four or more terms, so look, this one, take a look at the adding and subtracting. So I've got 1, 2, 3, 4 terms. So 4 or more, we're just going to call them a generic polynomial. Okay, there's names for them, but we're not going to focus on those names. What we really want to keep up with right now is monomial, binomial, trinomial, and we'll call everything else a polynomial. Okay, so far we've talked about classifying by degree. You got to look at the highest exponent. We've talked about classifying by the number of terms. You got to count how many terms are in the expression. And then there's something called standard form. For an expression to be in standard form, you're going to go in descending order. Descending means big to little. Okay, with the term with the highest exponent goes first, then the term with the next highest exponent goes next, and so on. So we're going to do some examples here so you kind of see what standard form looks like. All right, let's go ahead and flip this over to the back and try some of these. So we're going to classify each. For degree, remember we're looking at the highest exponent. So I like to look at the variables and look at the exponents. M to the fourth, that's M to the first because there's not actually an exponent there. It's an what we call an understood one. And M cubed, or M to the third. The biggest number, the highest exponent, is 4, so that's our degree. If our degree is 4, look on the other side, with a degree of 4, we're going to call that quartic. Okay. Now, number of terms. Remember, terms are separated by addition and subtraction. So we got, there's a term and then addition. So here's a second term, now subtraction. There's a third term. So this has 3 terms. We call a polynomial with 3 terms, we are going to call it specifically the trinomial. Now, standard form, this is you didn't see any examples of this. Remember, it said the term with the highest exponent goes first. So I already said the 4 was the highest exponent, so 3m to the fourth is going to go first. So 3m 4. The next highest exponent is 3, so I need the whole term. Do you see how there's a negative sign in front of that? That's the entire term right there, so I'm going to write minus 8m to the 3. And I've already used this one. The only thing left is the next biggest exponent is this m to the first, and that's a positive 9, so we're going to say plus 9m to the first. You do not have to put that one there. I just put it there to kind of help you see. Now look at your exponents on the m's. 4, 3, 1. That's descending. It's biggest to smallest. All right, let's try it again. So let's take a look at degree. That's your highest exponent. So look at the variables. This is just a single x, which means it has an understood 1 exponent. So that's a 1, that's a 3, that's a 2, and this has no exponent because that's a constant. So the biggest exponent is 3. So the term that's associated with that is this whole term right here. Negative 4x cubed. Oops. So the degree is 3. So when you have a degree of 3, that's called cubic. The part that's the degree is just the exponent. So I don't want you to worry about putting the negative 4x. Okay? The degree is 3. Number of terms, 1, this x, then there's a minus sign. Here's another term, then a minus sign, then another term, then a plus sign, then another term. So that's 1, 2, 3, 4 terms. When I look at my notes for 4 more terms, we're just going to call it a polynomial. I'm putting the 4 there to help me remember. Polynomial. Okay. Now, standard form, your term with the highest exponent goes first, so you have negative 4x cubed. What's the next smallest exponent from 3 would be this one with 2. That is negative 3x squared, so we're going to write that next, negative 3x squared. Then you have x to the first, and that number, that's actually positive because there's no sign in front of it, plus x. And then your constant's always going to be on the end. If you have a constant, it will always be the last term because it has no exponent. All right, so let's take a look. The degree here, we have 2 exponents, 1 exponent, no exponents. So 2 is the most. So that would be a 2 is your degree. And if your highest exponent is 2, it means it's quadratic. The number of terms, there's 1 and then a plus. So there's 1 term. The plus is telling you here's another term, then another plus, there's a third term. So there's 3 terms. If there's 3 terms, we're going to call this a trinomial. And then standard form, you want the highest degree first, then the next highest exponent, and go on, descend from there. So the highest degree is 2. So that term that goes with it is 9y squared. The next biggest is 1 plus 7y. And then you have a constant. So that one was already in standard form. That was a little bit easier for us. Okay. Now let's take a look at this next one. So the degree, we have a variable w. Remember, if it's just a variable and there's not a number typed in, it's actually a 1. W to the first. Well, that's the only exponent that we've got. So the degree is 1, and if you look at the other side, our notes told us that a degree of 1 is actually linear. Okay. Number of terms. Remember, terms are separated by addition or subtraction. There is no addition or subtraction in this problem. So there is 1 term, and the word we want to use for 1 term is monomial. Okay. And standard form. Well, if there's only 1 term, there's only 1 standard form because that's the only thing there is. So just be W. All right, let's try that again. Let's take a look at number 5, 257. Okay, so the degree. Is there a variable? There's no variable. Do you remember what was said if there's no variable? There's no variable, so we call that a constant. The number has no variable, so it will always be 257. There's not a number I can plug in that's going to change it. You would need a variable for that. So number of terms. Now be very careful looking at this. Remember, a term is separated by addition or subtraction. There is no addition or subtraction in this expression. Okay, so there's only 1 term. There's 3 numbers in that, but it's 1 term, so we call that a monomial. And when there's only 1 term, your standard form, it's always already going to be in standard form because there's nothing to rearrange. All right, one last example before you try the practice problems. So your degree, look at your variables. What's the highest exponent? If there's nothing written there, remember that's a 1. So if your highest exponent is 1, that's called linear. Number of terms separated by addition and subtraction. So we got 1, 2 terms. If you have 2 terms, it's called a binomial. In standard form, the highest exponent, what's the term with the highest exponent, would be negative c. So that's going to go first. And then we're going to descend from that. The next one is 15. That's actually a positive 15, so we're going to write plus 15. All right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.